Wherever you get your drinking water from, the tap, a bottle or a source, your water will not just contain pure H2O. But what is in your water, and more importantly, what should definitely not be in there? Welcome to the water treatment lecture about water quality aspects. My name is Doris van Halem and I'm an assistant professor in drinking water. Today I'm your lecturer and I will introduce you to the major water contaminants, water quality requirements, and basic water quality compositions of rainwater, surface water and groundwater. First, I will provide an overview of the key compounds in the water and why they are important for safe drinking water supply. This overview consists of the following groups: undissolved matter, microorganisms, and dissolved compounds. The distinction between parameters cannot always be made very clearly. A good example are the odor and taste of water. Odor and taste are subjective parameters, which cannot be detected by any device. The acceptable taste and odor of water are determined using consumer panels to detect any unpleasant flavor or smell to the water. Well, let's get back to the parameters that we can measure. Undissolved matter consists of large or small particles which have not been dissolved in the water. A distinction based on size is made between suspended and colloidal matter. The diameter and specific gravity of particles are important for removing them from the water. Colloidal particles are smaller and have a specific gravity similar to the water. Colloidal particles generally have a negative electric charge and their electrostatic repulsion makes them difficult to remove. Colloidal particles give color and turbidity to the water. Suspended particles are of mineral or organic origin. Mineral suspended particles originate from sand, clay and other inorganic soil sources and enter the water as a result of erosion. Organic suspended materials originate from the decay of vegetation and from the discharge of untreated, domestic and industrial wastewater. The rivers in Europe have a suspended solid concentration of approximately 30 milligrams per liter, while tropical rivers concentrations can rise as high as 10,000 milligrams per liter. The amount of suspended and colloidal matter can be expressed in multiple parameters, including turbidity, suspended solids concentration, and particle size distribution. The second group of key compounds in water consists of living creatures, which you most often cannot see with the naked eye. In nature, water contains all kinds of organisms, and they are present in large numbers. Also in drinking water, many different organisms are found. Higher organisms, of which a list is depicted in the slide, have a size between 0.05 and 10 millimeters. And just to give you an idea, a cubic meter of water may contain over 50,000 of these organisms, which gives the impression of a large zoo and seems unsuitable for drinking and to be avoided by vegetarians. However, fortunately, a characteristic of most higher organisms is that they are harmless to the human health. Their presence in drinking water is only aggravating if they are detectable by the naked eye. Also, smaller microorganisms, such as bacteria, can be found abundantly in water, and the majority of them does not affect your health. However, there are also microorganisms that are harmful to human health, the so-called pathogenic microorganisms. Pathogenic microorganisms, or pathogens in short, are not present in water by nature, but they enter the water through feces and urine from humans and animals. Pathogens have difficulty to survive in natural water because the temperature of water is lower than the body temperature. An important source of pathogens in surface water is the continuous supply of untreated or not fully treated wastewater from domestic and bioindustry. Pathogenic microorganisms can cause different diseases, which may become epidemic rather quickly. They can be divided into three main groups, each with their own individual characteristics. Protozoa, which are single-cell animals and can cause diarrhea and stomach complaints. Bacteria, responsible for typhoid fever and cholera. Viruses, the smallest organism of these groups, and responsible for hepatitis and polio. There are analytical techniques to determine what pathogens are in your water, but for safety reasons it is preferred to measure indicator organisms and not the real disease-causing organisms. For bacteria, coliforms or E. coli are used as indicator organisms. They can also be found in human and animal feces, but can be more safely cultured and counted as colony-forming units per volume. For viruses, indicators are used called bacteriophages, which can be counted as plaque-forming units per volume. In the guideline of the World Health Organization, it is stated that when testing a 100 milliliter sample, no E. coli may be found. Dissolved compounds in water can be divided into inorganic and organic compounds. A subdivision can also be made based on the concentration present. Macropollutants for concentrations over 1 mg per liter and micropollutants for concentrations below 1 mg per liter. This was a quick overview of the main water parameters. We will now take a closer look at the water composition of different sources based on the hydrological cycle. Rainwater, surface water and groundwater. Let's start with the rainwater. When rain is falling from the air, it is initially very pure and does not contain contaminants. However, we can still list quite some ingredients in rainwater drops, namely gases, including nitrogen, carbon dioxide and oxygen, but also dissolved minerals such as sodium chloride. Rainwater has, because of excessive carbon dioxide, a relatively low pH, between 5.5 and 6.5. And an interesting fact is that near coastlines, sodium chloride, or salt, concentrations can rise from 5 milligrams per liter to values as high as 25 milligrams per liter. Pollution of rainwater can happen in the air, for example when dust from industry is caught by the raindrops, but rainwater can also be polluted on roofs before it is stored in rainwater harvesting tanks. A more widely known form of pollution is acid rain, caused by the exhaust of gases by cars and industry. Also, in areas with extensive agriculture and use of fertilizers, the rainwater can be polluted with ammonium. To summarize, rainwater contains gases and some salts, but can generally be considered a safe source for drinking water. However, its purity can be threatened by contamination in the air or on the ground. Of course, surface water will also contain rainwater, as rainwater within a catchment area will partially end up in rivers or lakes. However, the main source for river water is mostly snow from mountains, such as the Alps for the Rhine River, or the Himalayas for the river Ganges. Initially, high in the mountains, the surface water is very clean. But because surface water mostly consists of open water bodies, it is very prone to all kinds of contaminations, including erosion, algae blooms and wastewater discharges. Let's take a look at the River Rhine in the Netherlands during the previous century. Surface waters were highly polluted at many locations in the Netherlands, and the Rhine River was even called Europe's sewer. All kinds of industries and cities used the major rivers as sewage systems. Wastewater entered the Rhine untreated, causing a steep decrease in animal and plant populations. Fortunately, more and more people became convinced that things should change, and treaties were signed between the different Rhine shore states. The Surface Water Contamination Act was adopted in the Netherlands in 1970. The quality of surface water has improved since, but there is still a long road ahead before the natural equilibrium is restored. In dealing with pollution, a difference is made between point and diffuse discharges. Point discharges have a high concentration of pollution issuing from one point. Examples include effluent of wastewater treatment plants, overflows from sewers, and incidents. Diffuse discharges are located throughout the catchment area of a river. Examples are runoff from fertilizers and the use of pesticides. Therefore, diffuse discharges are generally more difficult to cope with than point discharges. To summarize, the composition of surface water typically consists of suspended and colloidal solids, such as clay and sand and organic material, gases, like rainwater, such as nitrogen, oxygen and carbon dioxide, and dissolved compounds, such as chloride, nitrate, calcium, and even heavy metals. Contaminants, such as protozoa, bacteria, viruses, but also pesticides, fertilizers and medicines. Well, the last source in today's lecture is groundwater, which can roughly be divided into phreatic aerobic groundwater and confined anaerobic groundwater. Depending on location and depth of abstraction, the water quality composition will vary, Because of long retention times in the water underground, the water is able to dissolve several salts or minerals from the soil. Also, chemical or biological reactions may dissolve from compounds into the water. The consequence is that the concentration of inorganic salts in groundwater is significantly higher than in rainwater. In aerobic water, oxygen is present, and in calcium-containing aquifers, the abstracted water may be supersaturated with respect to calcium carbonate. On the other hand, sandy aquifers without lime sediments, the water can be very aggressive due to carbon dioxide concentrations above the equilibrium concentration. In coastal areas, it is also important to determine the salinity of the water, as saltwater intrusion may result in brackish groundwater. Anaerobic groundwater may contain elevated levels of iron and manganese because of reductive dissolution in the presence of organic material. In this process, also arsenic may be released, which is a serious threat to human health. Other compounds found in anaerobic groundwater may be ammonium, methane, and hydrogen sulfide. To summarize, parameters to take into account for the composition of groundwater are dissolved salts, such as sodium chloride and calcium carbonate, inorganic transformation products, such as iron and manganese, and organic transformation products, such as methane and hydrogen sulfide. Well, now you know the main parameters in our planet's drinking water sources. We have come to the end of this lecture, so I want to thank you for watching. And please use the discussion board for your questions.